Sec 1 2013 question 2. Consider this function. We'll type that into our calculator and then define it. There it is. Find the values of m such that f of x equals m, so it's really y equals a particular value where it has exactly one solution. Best way to look at this is to use a graphical approach. So there's our graph, and we want y equals something to cross the graph exactly once. That's what this basically means. To show you what's going on, maybe I'll just put f of x or y equals 1 through there. Put that graph back in there. Might just zoom in, see what's going on. So that currently cuts the graph twice, but we only want one solution. You can see that that's there at the turning point. You can find the turning point graphically, but that will won't give you an exact value. So the best way we do this is through interactive calculation. F max, put in f of x, okay, and there you have it. So the maximum value is 27 over 16. So the values of m for which f of x equals m has one solution is m equals 27 over 16. Okay, let's just resize that. The function is formed by reflecting the graph. So a reflection in the x-axis is a negative, and it's f of x. And then we translate the graph 2 units up, which is plus 2. We can just enter. So that's our equation, and we can just write that down here. We'll call that h of x. In fact, we can get our calculator to define it as h of x. Just choose h there. So there we've got that. Find the values of p for which both solutions to the equation h of x plus p equals 2 are positive. So we might just do that again. We'll sketch, clear that. We'll sketch h of x. So find the values of p for which both solutions to this equation. We could put in 2. We could graph 2 as well. Put h of x back. Or you could realise that h of x plus p equals 2 is the same as saying h of x plus p minus 2 is equal to 0. So it's basically just shifting this down by 2. But that's okay, we'll just have a look at this part of the graph. And we want both solutions to be positive. You can see there's one solution there and one solution there. But these solutions are not positive. That solution is 0. So to get these solutions to both be positive, we need to shift the graph of h of x to the right. And the only way you can shift the graph of h of x to the right is if p is negative. So p has to be less than 0. Describing the sequence of transformations, well, your graphing calculator is not going to help you there. There's a dilation factor of half from the y-axis and a translation in a negative direction of the y-axis of 2, so you would write those things down there. The graph of y equals h of 2x minus 2 passes through the origin. Find the other x-intercept. Your calculator can help you there. And I'll just resize that. So we want h of 2x minus 2. And so we've got that graph there. There's two ways to do this, I suppose. Just grab that and graph it, or define it as something else. Doesn't really matter. And we want to find out when that passes through the origin. So we want to find the other x-intercept so we can graph this. Put up the graph. Might just clear the other graphs. We'll draw that. Might just zoom in there. So it passes through the origin there. What's that x-intercept? Well, to find the x-intercept, we're really solving this equation. So it's x equals 0 and x equals 1. Find the values of m for which the equation has exactly 4 solutions. Again, we can do the absolute value of g of x. You can, if you like, define that as another function. We could call that, we'd use h, we'd use g, maybe we can use p. And we'll just clear this and sketch the graph of it. And so we want the values of m for which the equation as listed here has exactly 4 solutions. So it's a horizontal line that has exactly 4 solutions, and you can see here that it has 4 solutions, 1, 2, 3, 4, between this turning point here and this one here. We've got 1, 2, 3, 4 there. So we might just zoom in on that to just check. Oops. Actually, I think that is 0. Just resize that. So really it's going to be between 0 and this turning point here. It doesn't, the values of m, we could do that with an exact value or just find out using gsolve our maximum, and it's 1.6875 there. So the values of m for which the equation has 4 solutions, 1, 2, 3, 4, is between 0 and 1.6875. Let's swap. If I drew, just as a additional, if I just sketch the graph of g of x, you can see here that when we do the absolute value, that intercept there is actually going to be 0. It doesn't look like it, but it is actually 0, so we'd have to be careful with that.